Hi everyone, this is Greg Shaw. I'm here to show you some pretty cool things that we've been working on in the Forward project uh, to take your GUI, your 4GL GUI screens and surface them in the web as a first-class web UI. And we don't just do this with like onesie twosie screens. We take all of your screens over using automation, and we've got some really cool things that we can do to integrate web user interfaces with your converted ABL code or 4GL code, and I'm pretty excited to show all this to you. Everything that I show today can be done by you. You can download Forward. We're not using OpenEdge here. We're using Forward on the server side where the converted app runs. It's all Java. You can keep developing in the 4GL and just reconvert it and deploy it in Forward. So you don't have to switch to Java to use this technology. And in fact, we are adding really quite a large number of enhancements to the 4GL syntax itself that are extensions that would only exist in Forward, so they wouldn't be compatible with the original OpenEdge ABL. But in our version of the language, we're doing extensions that give a lot of new capabilities, making it better than ever to develop 4GL code and 4GL applications. In the browser itself, I'm logging into a custom web app. It was written just from scratch by hand, but it has a control here, a rectangular visual element called an iframe, and that's essentially a way of dropping in another web app inside a larger web app, if that makes sense. So we've got a custom web app on the outside, all right, that is written in just pure web technologies, and then we have this piece which connects. It's actually running our Forward client, web client, and it's running that web client in what we call embedded mode because it's part of a larger screen or application. You can see here that you can still interact with that. So it's just doing the rendering, and everything else runs remote on the server. And it's also interacting with the user, so it's got all the kind of keyboard and mouse interaction, but it's very thin, and then most of the real logic and processing happens remotely. One of the things that I want to show is that how this can be responsive. So you can see here, where as I'm changing the size of the browser itself, the different controls are refactoring where they are, and the layout kind of refactors, and we even get a hamburger menu when you go small enough. And you can click on that same menu, just whether it's the hamburger menu or the larger form here, where we basically get everything on the screen at once, and it goes back. You're still able to kind of change your screens, right? So we're interacting from the main the containing application with the iframe, and using an API in this case that lets us control what screen to open new screens or close screens down, or to hide them, unhide them, things like that. Beside this header with the menu and the footer, we see three other controls. All right, and these are written in pure JavaScript. We're just using controls they're out there. We didn't write these ourselves. We just are using controls that already exist, and we've customized them in this case. And in some cases, we're just using them by configuring them. In other cases, we've made changes because they're open source, just like Forward. So this first one down here at the bottom is a calendar. Where it displays color coding as what would be termed a heat map. So we get this, we change the color of a particular day based on the level of whether the hotel is empty or full. And the blue dot represents today, and if we hover over, we get some details about the utilization and the date. And then this utilization data comes from the converted 4GL application. It has to come from somewhere, and the entire app is running over on the server, and we need to drive that with this front end code. We make up calls that are essentially like app server calls from JavaScript to the converted ABL code to get this data. I know that kind of thing is possible with other technologies, but there is no other way of having your screens actually integrate directly out to the web. We're not doing remote control here. This is actually the screen with being rendered in the browser. Now we've got some other controls. This is an aster plot that is giving you details about utilization by room type and the amount of revenue. Kind of the arc lengths here relate to how much revenue can be generated from that room type, and that's of course driven by the server and the converted ABL code and data as well, and so is this tabulator control, which gives you some nice capabilities with you don't have to change your queries in order to use the sorting and all of that kind of stuff, which is common with data grids and various things nowadays, and we've got tooltips there as well, showing us our visual, allowing us to visualize our data in some interesting ways. So what we have here is these different JavaScript controls, and they're integrating with the back end data in a pretty seamless way. But we have actually quite a few other ways of integrating these together that are not possible with any other technology out there. So we're pretty excited about that. Let me summarize some things first before I before I move on to the next part of the demo. So we've got a pure web application. It's a single page application with no reloads. JavaScript controls are bound to the converted application data. That client is a separate document loaded in an iframe, which is a rectangular visual element. It's that the main document of the containing app and the iframe document can have different origins, which in web terms means they're different. There's a security isolation between those two documents, even though one is contained within the other. And we use a technique called cross-document messaging to communicate between the two in a way that doesn't breach security. The iframe itself, which I'm kind of showing expanded out here so you can see it more easily, is also pure web. We are not using any plugins or applets there. The converted ABL code or 4GL code runs in the Java application server, which is remote, but the screen renders in this iframe, and non-modal windows. So your normal kind of windows are going to be chromeless, which means no title bar, borders, or any of that kind of stuff. It's just the client area, if you will, of the window. And dialogues are modal, and there's like a shading overlay that basically enforces modality, and those do have Chrome. There's an API for control of the screens from the containing application, and that there's an app server API that allows the containing application to make calls up to the forward server and to get access to all that wonderful data that is up there, as well as to invoke code directly. You don't have to get data back. We're not mimicking a table structure or anything like that. We're actually calling app server in an app server like way, and essentially it's a JavaScript, I should say, app server client. And we've also got a pub sub integration that we're going to show that I think is really cool. But I'll more details about that later. Let me just explain the up calls first. So you can do this. This gives you the capability of doing a completely custom web UI to whatever level of capability you want. You can totally leverage any kind of JavaScript tooling, controls, frameworks, any of the web technologies that are out there. We're agnostic. And you make direct calls from JavaScript up to the converted 4GL code. You can call external procedures, Optionally, you can do it persistently, and if you do it persistently, you get back a handle. And if you do it in that mechanism, use that method, you can call internal procedures and functions on that handle just like you would in normal app server capability. And we integrate with JSON, so the JavaScript code can pass data as JSON and get it back as JSON, which is the normal way you would do this kind of thing with JavaScript. And it's easy to use data binding with JavaScript controls, and we're using a technology called D3 here, but you can use anything that does that. And we're basically binding these controls to the converted data. Okay, so I mentioned before that we have some new ways of integrating pure JavaScript controls and technologies with converted 4GL code, and I'm going to show some of these right now. They're pretty cool to see because it opens up a whole new set of capabilities and possibilities for your 4GL application. In this case, we're on the Available Rooms tab. You can see that there's a check-in date of today and a checkout date a week from now, right, by default. And we can see that actually over here on the JavaScript side, we're showing kind of current day information. And if we look, so we can see up here, room 107 is a double C view with a C view, all right? And we can look at that, and the C view room type is 66.67% utilized. We can see that again kind of here, and 4 out of 6 rooms, right? And we get this is an overall number here, but if we then go and do a check-in, so let's bring up the check-in dialog. Let's add a guest, John Doe, and we'll add that person in. And now we're going to do a check-in. So let me make sure that I use room 107. All right, so remember we looked before, and this double C view is 66.67%, and here 4 out of 6 for the same percentage. And we're about to do a check-in for this entire next week. So essentially this space right here. Watch this space when I do the check-in. Remember, this is JavaScript over here, here, and here, and this is converted ABL running on a back-end forward server. Notice how the blue has come and highlighted and how this has changed. It's now 83.33, as is this. We're now 5 out of 6. I'll show you this same technique, but from a different tab. So we're making changes on the ABL side. Let me type John Doe, do a search. There it is. I'm going to do a delete. Again, we're deleting that check-in. Watch what happens here, here, and here. I'll confirm now. 4 out of 6 again. The blue happened, and this. So, what does that mean? How did that work? What's going on? Because that's pretty cool, and you can't really do that easily, right? Because we're making changes on the 4GL application side. We're not changing stuff in JavaScript. We're changing code just using traditional standard 4GL code. We made a change. We deleted something. We added something to a table. In this case, what happens is we're getting an add of a new record in the stay table or a delete of a record in the stay table. And those execute database triggers as a result, which do a publish of the room utilization event. Now this is, we're showing the original 4GL code here. Of course, when it's running, it's actually converted into Java. But you can do all your development in the 4GL, so it's the same, it's equivalent. We're duplicating that behavior such that it's a complete drop-in replacement for your original app. But when that publish happens on the 4GL side, it will be routed down to the JavaScript subscriber. Well, our JavaScript code has done a subscribe of the room utilization event, and we've passed it a function as a callback for when that event occurs. And we basically parse out the parameters, because of course we're passing the start and end date down. We parse that out, and we use that to basically update all of the utilization data on those different controls and to draw the highlight. So this is a subscribe in JavaScript responding to an event that occurred in converted 4GL code. And the converted 4GL code had no idea that some of the subscribers are JavaScript clients. They don't know that. They don't care. There's nothing special we did in the 4GL code to make it enabled for JavaScript. Yet, we've got this beautiful integration between the JavaScript controls and the converted application control. All right, let's go back and show some more things, because it doesn't end there. And by the way, imagine trying to recreate or duplicate that kind of capability without using something like forward. We're enhancing these capabilities or adding these enhancements directly in the forward technology itself. We're providing new capabilities at the language level and at the infrastructure level, such that you don't have to write some kind of crazy polling up call with a polling thing and tries to detect when something has changed. And I don't know. I mean, you could maybe do something along those lines. It would be kludgy and a big mess and a lot of code. You saw the code that we used. It's pretty small. It's pretty clean. It's pretty understandable. And it's the kind of thing you would want to be able to do. At least that's our belief. Okay, so now let's look at the opposite direction, where we're publishing from JavaScript. So we can basically look at this heat map. First, let's go back to the available screen. You'll see again we're back to our kind of that week that's available, or by default is set, and we can make a selection of a specific date. All right, so I will click on tomorrow, the 15th. Now, what just happened? Notice that the check-in date and checkout date is now 15th through 16th instead of the default 14th through 21. And also, maybe you didn't see it, but the data in this available rooms list changed. All right, we'll do it a little bit more. Watch again this and this when we now do a swipe, because we can do this for an entire range there. We've now changed this range, and it's responding to our JavaScript events. All right, how did this work? So in this case, we're getting some kind of either a click or a swipe in a JavaScript control. It's executing this date range selected function in JavaScript, which does two things. First, it kind of goes and tells these controls to update their data by using up calls, those JavaScript app server calls essentially, to get their data. And it pulls out the start and end date and does a publish of the capacity zoom event, and it passes in the start and end date as parameters. This gets routed up to the forward server, where the original 4GL code would look like this. We have done a subscribe to the capacity zoom, and we do some processing of the start and end, and we pass that into check availability, which basically does, we update these controls and refresh the data in the browse. All right, let me show you a different version of the same thing. Now, obviously, you can see here we've swiped, and we've set this up so that it's April 15th. It's the same range, and all these controls they're all kind of synced up, right? And now if we go down here, we can see we've got a list of by type. But up here we see that we're showing all the data for all rooms because we don't have any specific room type selected. We could, of course, come down here and select the C view, and you'd see that filters our browse down to just the C view values. I'll put it back to all rooms. I'll go down here and click on C view. Oh, there we go. It has updated this control and refreshed the available rooms list. Okay, how did that work? We are basically hooking the row selection, and that calls a row click function in JavaScript, which pulls out the room type ID and the start and end date, and we do a publish of the the event called room type pick, and we pass those 3 values as parameters. And then that gets routed up to the forward server, and the converted 4GL version, which this is the 4GL code that backs it, we have subscribed to room type pick, and in that procedure that gets called, we basically assign the date values and assign the room type, and we call the check availability procedure that will basically refresh all of this. So again, what we're showing here is the capability to have JavaScript code publish events and have those seen by the converted ABL code. And this is something that you could simulate with a little bit more code by basically upcalling to something that then did a publish on your behalf. But what we're doing is we're providing that back in a really clean, simple syntax all the way down to JavaScript, making it very easy to integrate, publish, and subscribe both directions with the converted ABL code or 4GL code. All right, now I'm going to show one more thing that I think is really going to knock your socks off. So what I've got here this is a different client of Forward. This is the Swing client. All right, it's a fat client. You can see it's outside the browser. All right, it's all written in Java. Let me log in, and it runs with your original application exactly the way it looked in the original system. So we're not running in embedded mode here. We're running truly the way the application used to look. It's a fat client install in this case, whereas the web is not. So and we can switch tabs and do all the things you normally used to do in the original application. But the idea here is that I'm trying to show is this is it's a separate session, right? It's thought by the application's perspective. We have 2 different users here. We have a user that's logged in this Swing application, and we have a separate user that's running here. All the publish subscribe we've been doing in this browser application has all been within one user's session, which is how it works. It would work in OpenEdge. I mean, without the JavaScript stuff, but that's how pub sub works in OpenEdge ABL. In our version of the language, we have an option to go global, to go cross-session is another way that we call it. We call it cross-session publish subscribe. So we've got a separate session here, and we're going to process a reservation. So let's add a reservation. And actually, before we do that, let me go back here, and I'm going to highlight, let's see, we're going to go to this date, March 10th, all right? Because we're going to check somebody in across the month of, May 10th. We're going to check somebody in across the month of May. And we want to see, there's this room 201 right here, okay, is available on May 10th. And you can see it's a double, so it's 88.89% utilized, and you can see the double up here, the same value, 8 of 9 rooms are being used. All right. So now let's go back to our separate session, some other user somewhere that is taking a reservation. And we will create choose room 201. We will choose, I guess, let's say we want to go to May 1st, and this other one I'll just type in. We could, of course, do it now with the calendar pop-up, but it's faster to type it. All right, so we're making a change to the reservation table. That will change the utilization for the month of May for the double, right? And for and on the particular date of May 10th, it will change the specific number from 8 to 9, and it'll change this value to 100%. If in fact we can respond to that, let's see. Oh, we can respond to that. We're in a totally different session. We've highlighted this. We've changed this to 100%. We've changed this to 100%. It's 9 out of 9 rooms now. And this is a completely separate session. What we're doing is we're allowing, this isn't by default. You have to enable it by adding a keyword to tell your publish and subscribe that they're global. By default, they're within a single session, which is compatible with how OpenEdge works. But we're giving you new capabilities that we're adding to our version of the language that add a completely different paradigm for how you can leverage 4GL development. So we're very very excited about all of these capabilities. This I think it changes things significantly. I want to address a common question that we get. So, we've highlighted here how we've added quite a bit of power of being able to do some really unique things with custom web controls and integration of all your screens. And we use automation to take every one of your screens over to the web, right? And you can integrate that with a larger web application in a first-class way, and we can do really unique things to communicate between those and make a really modern, cool web app. But we often get the question that people say, well, that's great, but what about all of my screens? You've brought over 1,000 of my screens. I didn't have to do a full rewrite or of those, or even a partial rewrite. I get all of that over for free as part of using Forward. But those screens look like the original 4GL screens, which are dated. They don't have the modern controls and the modern look and feel. And we say, yeah, we agree with that. That is a concern, but we have a plan for how to solve that problem. How to make it possible for you to write 4GL code that is a first-class web UI and have the 4GL portions of the screens looking really great as part of it. So it's a 3-part plan. One part we've already delivered, and that is what I'm showing you here, custom themes. So this is part of version 3 of Forward. In my the previous GUI demo, I showed the classic mode, but recently we've added Windows 10. So we've got 2 themes, Windows Classic and Windows 10. All right, and for those of you that don't know, we actually, when you're looking at the UI that we're rendering, you're not actually looking at a Windows UI there. We are rendering every widget ourselves, every button, every drop-down, combo box, browse, text, fill-ins, everything is drawn by the Forward Java code. And what we've done is we've abstracted the part that renders all the widget drawing itself is abstracted into a set of pluggable Java classes that represent a theme. And you can control, obviously colors and fonts, but you can control the widget drawing down to the pixel level, And you can even override things just at a specific widget type. So just how the button border or button shadows should draw, that kind of thing. It's very, very granular. So each widget specifics for how it draws, can be controlled. And you can do this by, of course, you can build your own theme from scratch and plug it in, because it is pluggable. But the cool thing that is possible is you can subclass our themes or someone else's theme and override just the parts you want. So with a very small amount of code, essentially very high leverage, because when you plug the theme in, and it's plugged in at runtime by configuration, basically, so you can choose the theme, and you can even ship multiples and choose which one you want. But you can basically, you get to upgrade every ABL screen, every 4GL converted screen is upgraded at the same time. And you can have even multiple clients running different themes on the same server, simultaneously. So you can have different users have different themes. And so this is one way that we know that people will get a lot of value and real high leverage way. Without making code changes everywhere, you can basically do an upgrade on the look of it completely. And you could even customize basically, if you have like a containing web app that needs to that has a very specific look and feel, you can absolutely customize the theme and have all your ABL screens or all your 4GL screens completely matching that, right? So that's item 1 on our 3-part plan. That's already delivered. Item 2, better widgets. So yes, even though you can do a theme and control all your current widget usage to make it look better, we want to actually give you new widget capabilities. And that comes in by improving the existing widgets to add capabilities that are not there in what we would call compatibility mode, which is the default mode that we run in, because what we're providing you is a drop-in replacement for the original OpenEdge environment, right? Our code works the same way so that your app works the same way, because we don't want to break your app. But if you choose by configuration or by using some of the new keywords we're going to provide to select the enhanced mode, then we can drop the worry about compatibility for your application and just upgrade all the widgets across the app to use the enhanced versions. Browse is a good example because there are a lot of features that people want in Browse. Column sorting and column filtering at the widget level is a big one, or big ones, because the idea is today, if you want to do column sorting, you have to basically reopen your query or change your query and reopen it, right, for the browse in order to sort differently. Same thing for filtering, if you want to implement filtering. And so a lot of people have all these extra controls that are kind of there just to give the user the ability to specify some filter expressions and to change the sorting, and then kind of refresh the query. And there's a lot of code in your app to do that potentially. At least that's what we've seen in many apps. Well, that's not necessary if the widget itself can do column filtering, column sorting, and we're going to give you new controls over the headers, give you the ability to hyperlink a particular column. So change the column def to have a hyperlink keyword that passes that, and you give it an event name, and when the user clicks on a hyperlink in that column, it'll do a publish of that event and pass the column value, the self value to it. So you can kind of do some new things. There's pagination controls. This one I love, direct export to PDF, CSV, and Excel. Think about you've enhanced the look and feel of your browse, and now every browse in your application can now be exported by the user to PDF, CSV, or Excel without any extra code. No extra code. So many people I've seen have all kinds of elaborate reporting capabilities built to generate PDFs or CSV output or Excel or some mixture of the three, and typically it's all very, very complicated and one-off stuff that represents a massive amount of code. That's totally unnecessary if you can just deliver a browse that has some good formatting and let your user every browse in your app becomes essentially a report generator without any extra code. So we're excited about this. We know that you can cut out all kinds of stuff that you do today manually in your code that don't have to be there just by upgrading the browse widget itself. And because Forward basically can be, if you join our community and work with us on this, we can basically create enhanced versions of every one of the widgets that already exists so that you're upgrading your app across the board with no necessary coding changes. Now, also imagine that we add new widgets. So again, it's for our version of the 4GL, but you get toolbars and tabs and trees and calendars that look like 4GL widgets because they are in the Forward version of 4GL. So view as calendar now, on a date variable will turn into a nice calendar to display, and the selection of it will edit the date value. I mean, that's the way it should be. You shouldn't have to do a calendar OCX or a .NET control or something and have the kind of more verbose integration that you have to do that. You should be able to use just 4GL syntax, create tree view, and go populate it and use it just directly from the 4GL in a nice, clean way. So all of these things will be first-class 4GL widgets. And the one I'm especially excited about is the data visualization widget, where we'll basically let you program an SVG model directly in the 4GL, bind to 4GL data, bind to events, bind the SVG events to 4GL callbacks, and basically totally visualize your data, even animate it in a really, really sophisticated way. Very excited about that capability. This is not yet available. The work is in process, and these images are just for illustration, so don't hold us to every pixel in them. They're just to give you the idea. But again, our idea here is with better widgets and with that custom theme control, all of a sudden the look of your app is beautiful, and it will render directly in the web and all of these different devices and so forth with you can be with you just developing in the 4GL, but you're making a gorgeous web UI. There's one thing missing, and that is dynamic layout, because all of that 4GL GUI code today is very hard-coded, right? Absolute positioning typically, and it doesn't resize. So if you resize the window, or if you run that same screen on a different device with a different form factor, resolution, size, and so forth, it will not handle that today. So we've seen some people that have done a kind of limited, pretty complicated solution for trying to manually write the code to reflow the layout of certain screens and what have you. That's of limited kind of capability, but it at least is a partial solution. We have a better idea. If you take frames in Windows and you encode some additional layout hints for the runtime, like layout equal columns, you add a keyword and you put that in on a particular frame, for example, and so forth. You can give the runtime itself enough information such that it can respond to window resize events and to device media queries in a smart way. So what we're showing here is, this example, we have a window that was designed to run on a desktop, and it's wide and not very tall. And we've got a frame that is roughly two columns, basically, that are roughly equal, and another frame that has equal columns here, but below it. And maybe these are like these buttons at the bottom are for your CRUD operations, and this stuff and the widgets up top will display data or allow them will go into editing, mode or what have you. All right, but let's say the user resizes this screen. Well, the runtime should be able to say, well, I know that this is set up in an equal column. This frame is set up in an equal columns mode, so I'm going to stack that all into one column because I know that we're in a mode where we're very narrow and very tall now. And that could be either because of a user resizing or because we get a media query for a different device. And we're being used on a phone, it's narrow and tall. And so we go into this this single column mode. And we likewise for the buttons, we have a second frame below and we stack the buttons because we don't have room for 4 columns. We only have room for a single column. All right, so now all of a sudden you've got this much more beautiful set of widgets and beautiful look that matches the rest of the web application, or or whatever the look that you want. And now we're responding to different devices and different resizing and shapes, and we're handling all of that responsiveness nicely. All of a sudden, you've got a first-class web application, but you've not had to go to school to learn how to program in JavaScript and how to do all the web stuff. You've programmed this all in the 4GL itself. And you can go back, and on the dynamic layout, it's possible we might be able to do, using our automation tools, to kind of come up with a good default for different screens based on how we analyze the widgets. But that's not foolproof, because there can be a lot of runtime choices that your code may make that we can't pick up or what have you. So I think dynamic layout will probably need some coding changes, not necessarily a lot, but some selected hints put throughout key windows in your application and keyframes to kind of give us the full knowledge we need. But you can, I think the other techniques that we've described are kind of totally can be implemented pretty much widespread without coding changes. But I'm confident that this will give you that capability of having a first-class web UI. So, all right, so what have we done here? Because I think it's pretty exciting and pretty game-changing. Today, nobody wants a Windows app, right? The dominant dominant app paradigm is web and mobile, and every company we know that has ABL or 4GL GUI is moving to the web, but that effort without forward, and to be fair, we know that people haven't known about forward, so there's this. The current plan didn't factor forward into it. So without forward, what was going on was refactoring the entire UI, or at least all the parts of the UI that had to survive, had to be refactored, the business logic separated out from the UI, right? And this is really, first of all, it's difficult. It's risky because you're going to cause breakage. When you do that across 500 or 700 or 1,000 screens, you are going to break things. And it's just difficult because you have to find all the different dependencies and remove them, and then you have to create an interface that can be callable and can achieve the same results, and you have to handle all the validation processing and other kind of the tighter dependencies that are deep inside your code. It's time consuming even for a single screen. It would surprise me if it wouldn't take 2, 3, or maybe more, maybe a week for each screen just to abstract everything out and separate it all out. That's a lot of work. And that doesn't even, then you still have to write the front end, right? You have to write the entire UI. Again, maybe you can drop a bunch of screens, but most of your UI is going to have to remain. You're going to have to write it from scratch in a native web, native mobile technology, and then connect and call that refactored code. This is, again, can you do it? Can you really do that legitimately for any kind of non-trivial screen in less than a couple of days per screen? Again, I would say probably 2 to 5 days per screen is expected. You're talking a week to 2 weeks of work per screen. You got 1,000 screens. You're talking minimum 20 person years you got to put in. You're talking 3 to 5 years, even if you put a team on it. That's hard. That's really hard. And it will take a tremendous amount of discipline to do it right, and it will take willpower. I mean, the political will of your organization to get behind it and stay behind it when you're 3, 4 years into it and you've got to keep pushing on and you haven't been able to deliver your web application yet. Or at least not the whole thing, because you've got to have some users keep going back to the old stuff for some amount of time. It's a long road, and there's a big opportunity cost, and you might lose some customers along the way, and you're probably, the investment in all this work just to get to web, and those same resources are not working on new functionality that can win new customers. So what we say is no, doesn't make sense, especially when you consider that the long tail, right? That your UI has a very small amount of screens that make up the majority of the usage of your app. And then, from there, the screens kind of tail off such that 80% of the screens are rarely used. Thus, they're low value. Well, it makes no sense to spend years and years and years rewriting all the low-value screens in your application to get to web. Forward provides a completely different approach. We get you there with automation, all of it, over in the web. We get you there in a very short amount of time. And every one of your screens comes over. And then we've got a plan for how you turn those into first-class web UI. Right? First-class web citizens, and we've got enhancements to the 4GL itself to give you completely new capabilities. So we're really excited about what we've got to offer. More and more of it is going to be rolling out over the next few months, and we thank you for your time. I thank you for your time. Follow us on social media. Go to www.beyondabl.com to get full details. Thanks again. We'll be doing more videos over time, so keep watching.